Hi, my name is Connor Stingray, and the speech I'll be giving today is the impact of forward-facing sonar in fishing. To start off, what is forward-facing sonar? Forward-facing sonar is a device that uses sound waves to detect objects in the distance, often used in fishing or marine practices. It allows an angler to look in real time at a view of what's out in front of the boat, including depth, fish, or bottom density. There are a few leading brands in the frontier right now. The first one being Garmin Panoptix LiveScope. They use a transducer to look down into the water to see fish and other obstructions in the water. Humminbird Mega Live and 360, they have a unit called 360 where it is just a little different. It shows bottom composition instead of just a side view. The last one is Lowrance Active Target, and they are a nice mix of both, three similar technologies by three large companies. Why fishermen benefit from forward-facing sonar? With the ability to essentially look into the world of water systems, we can see fish habitat in a brand new light. By trying different baits, colors, and presentations with multiple fish, an angler can get a quicker dial in on what works best, especially on new bodies of water that they have never been to before. This is a quick look at what the sonar looks like. So this is a submerged tree in a lake that is about 14 feet deep, and there's a school of fish right under it. So if I was reading this, I would see it and cast towards that and hopefully get the fish to bite. And why is forward-facing sonar so impactful in the industry right now? This tech is more and more popular, especially in commercial fishing use. Many people use it for companies for catching walleye, up to muskie, or even saltwater fishing to catch halibut and things like that off the coast of Alaska. For recreational anglers, it is also imperative that we, as myself, are aware of the natural resource of fish that we control ourselves. Another great use that makes this technology so impactful is identifying structure and depth changes in water. So for all of you that don't know, fish often resort to shady or protected areas. This includes panfish, which are species such as crappie or bluegill, or other fish such as walleye, northern pike, or perch, which are some of the common fish species around where I live in South Dakota. Many panfish stick to weeds on the outside because that is where they spawn in the springtime, and they stick their eggs to grass to let their babies hatch underwater before they become full live fish. Many fish also hang around trees because they can ambush schools of bait fish that swim around into or around them. Rocks are also a common place for them to live in deeper lakes because it's just another transition, and fish like to follow the transition all the way around the lake. With forward-facing sonar, you can identify all three of these with maximum efficiency. This right here is just an example of what it might look like. So this orange and yellow up here are bank, and then as it transitions down to this green, it gets just a little bit deeper, and down to blue and light blue, it shows a contour, which includes a rock inside of it. And if I was fishing it, I would fish down to there and pull up to see the maximum, to maximize the efficiency of myself and my time on the water. Another thing to talk about is barotrauma. With this new technology, a lot of anglers who are fishing deeper water, deeper than about 25 feet, fish that they pull up often suffer from barotrauma. Fish breathe in water due to gills and air sacs that contain oxygen, which lets them breathe underwater, which is why we cannot, because we do not possess air sacs, we have lungs. When fish are hooked and brought closer to the surface, these air sacs inflate, and they cause arteries to blow up inside of their brain and other common ways that blood flows through the body. And then this blood does not flow through to any of the vital organs, and then they experience what we call barotrauma. But why does it even matter to fish? In South Dakota, the limit of walleye is 4 per person, but if you were to catch and release one limit, the mortality rate of fish that suffer from barotrauma is 75%. So for every 4 fish that you're putting back into the water after you catch them, 3 of them are possibly dying, and that is not a sustainable rate to keep fisheries alive for years to come. Many of breeds like walleye are commonly found in deeper sections of the water column, so they are very susceptible to barotrauma. No matter how you handle them outside of the boat or putting them back in, there's not much you can do about it just by practicing better technique and having the knowledge to attain that. Other breeds such as panfish are up closer, but then as the season prolongs, especially in ice, they stay up in weedy areas and then they'll transition down to mud flats where it gets deeper, and then that's where they can also be found, and those fish are also susceptible to barotrauma. So in summary, we covered the 3 types of sonar that are led by Garmin, Lowrance, and Humminbird. We discussed the benefits of sonar, especially the benefits of the forward-facing sonar as well as down view. And we also looked at the overall management of fish and barotrauma and how this new technology is incredible, but unless we know how to use it, fishing may not be something of the future for our kids and many to come. Thank you for listening.